right, we're moving on to 8.3, and we're going to look at some other different types of graphs. This is going to be the last section we have of graphing in Chapter 8. So the first type of graph we're going to talk about is called a piecewise function. And all it means by piecewise function is it's a function that literally has more than one piece. This function has two pieces. Okay, you can see that both pieces are lines. So this top half of the function, it means that the graph looks like the line 2x plus 4 as long as your x is less than 0. And the second half of the function looks like the line y equals negative x plus 1 as long as x is greater than or equal to 0. So you notice the first thing they're asking us to do is to evaluate the function at certain values. So the first thing I want to do is I want to find f of 2. And the key is to plug that 2 into the right piece of the function. 2 is positive. It's greater than 0. So if I want f of 2, I have to plug it into this piece of the function. And if I plug it into this piece of the function, it would be negative 2 plus 1, which is negative 1. If I want f of negative 6, well, negative 6, my x is there negative, so it's less than 0, which means I'd plug it into the top piece of the function. So it'd be 2 times negative 6 plus 4, which would be negative 12 plus 4, which would be negative 8. And if I wanted f of 0, that would be this piece of the function, because this is the function for x greater than or equal to 0. So that would give me 0 plus 1, which is 1. And then don't forget that really just gave me 3 points that lie on the graph: 2, negative 1, negative 6, negative 8, and 0, 1. So now we are going to graph this piecewise function by making an f of x chart. Okay, so here's the deal. Let's go ahead and let's do the bottom. Let's plug some values in for the bottom part of the chart first. So the first thing we're going to plug in is 0. And we already actually did that. You get 1. Now let's start plugging in some other values for the bottom. So I want to go now bigger than 0. So for example, I can plug in 1. If I plug 1 into the bottom, that would be negative plus 1, which is 0. If I plugged in 2 to the bottom, which is totally legal because it's x greater than or equal to 0. If I plugged in 2, I already did that actually, but it's negative 2 plus 1, which is negative 1. Okay, so now I'm going to start plugging in values for the top part. Now, here's what you're not going to like, but just trust me, please. You have to also plug in 0 to the top portion of this function. I know it says x is less than 0, but you still need to plug in 0. And when we graph it, I'll explain why. If I plug in 0 to this top part of the function, you can see that I'm going to get 4. Now I want to go things less than 0. So let's go ahead and let's plug in negative 1. If I plug in negative 1, 2 times negative 1 is negative 2 plus 2 is 2. And let's plug in negative 2. If I plug in negative 2, 2 times negative 2 is negative 4 plus 4 is 0. All right, so now let's graph these values. So 0, 1 is right here. That is where the bottom part of the graph starts. 1, 0 is right here, and 2, negative 1 is right here. So that piece of the function looks like that. It starts at x equals 0. And you can see that the slope is a negative 1, so it makes sense that it's going down this way. Now, let's graph the top part. Now, we plugged in 0, and it is true. When you plug in 0, you get 4. But the thing is, you're going to put an open dot on that point because you don't want to actually include that point. But don't forget, if it says anything less than 0, it's talking about plugging in negative 0.1, negative 0.2, negative 0.3. But we're not actually going to plug those values in. Now we're going to go to negative 1, 2, and negative 2, 0. So this portion of the line is going to look like that. It's going to start at this open dot, and it's going to go through those points. You can see that if I were to continue that line, that actually has a line that has a slope of 2. So you could see that there's a slope of 2 there. It is a function, but because this is an open dot, this is a closed dot, it does pass the vertical line test. But again, I'm going to say the key is these values, you have to plug them into both pieces of the function. It will be a closed dot where there's the equal to sign, and it will be an open dot when it's just less than or greater than, depending on the problem. If you don't plug in that value twice to both, once to each one of them, you're going to end up with a part of your graph that isn't graphed. All right, so now we're going to do some shifting. So the first thing it says is let's graph f of x equals x. So you hopefully know that that is what we called back in 53 the identity function. It has points like 1, 1, 2, 2, 3, 3, 4, 4, negative 5, negative 5. It is the line that bisects the first and the third quadrant. Now, if I want to graph f of x equals x plus 3, my y-intercept is 1, 2, 3. And since it has the same slope, you'll remember that it's going to be parallel to that. So notice that this section is called vertical shifting. If I have a plus 3 at the end like that, it's going to be the exact same graph as the original, but every point is just going to be shifted up 3. It is a vertical shift of positive 3. This point on the original graph is shifted up 1, 2, 3. Every point is shifted up 1, 2, 3. So that is a vertical shift. What if it's not linear? What if we're talking about our parabola? This is our function that we graphed in the last section. So let's just quick graph that function again. You'll remember that it had the point 0, 0, 1, 1, 2, 1, 2, 3, 4, and then it had matching points over here. It looked like a parabola. So we'll do our best to graph that. So now look at this one. So this is our f of x equals x squared. Look at this one. This means that it's a vertical shift of negative 3. So in other words, all of the points for our f of x will be shifted down because it's a negative 3, 3. So our point right here will go down 1, 2, 3. So there's the vertex. And then if we just kind of follow the pattern, this point we got by going over 1, up 1, and then over 2, up 1, 2, 3, 4. So that's this point being shifted down 3. And then, of course, we have matching points on the other side. So notice it's the exact same graph. Oops, shape-wise, it's been shifted down 3. So vertical shifts are at the end. Let's talk about horizontal shifts. Look, see how this is inside the operation, which in this case is an absolute value? That means it's a horizontal shift. If it's inside. Another example, this I'm just going to use this as scrap, but if I had f of x equals x plus 2 quantity squared, that would be a horizontal shift. If I had the square root of x plus 2, that would be a horizontal shift because it's inside the operation. Okay, so let's first of all graph our f of x equals the absolute value of x. So you'll remember from our previous section, it looks like a V. So I'm just going to kind of go ahead and graph my V. This is why we reviewed those graphs, and you want to be very familiar with them. Now, for this one, let's go ahead and let's plug in some values. even though we know it's a horizontal shift, I want to show you something. So for example, if I plug in 0, I'm actually going to grab myself a pen. Hopefully I have one handy that will work. No, does it work? Yes, it does. Perfect. If I plug in 0, 0 plus 2 is 2, and the absolute value of that is 2. If I plug in 1, you can see I'm going to get 3. If I plug in 2, I'm going to get 4. Let's go negative. If I plug in negative 1, negative 1 plus 2 is 1. The absolute value is 1. Plugging in negative 2, I'm going to get 0. Plugging in negative 3, I'm going to get, okay, now look, negative 3 plus 2 is negative 1, but that makes it a positive 1. Let's go one more. Negative 4 is going to give me a positive 2. So let's plot those points. 0, 2, 1, 3, 2, 4, negative 1, 1, negative 2, 0, negative 3, 1, and negative 4, 2. Does everybody see that this is what that graph looks like? So my point is, look, let's specifically look at this point. It did shift 2, but which way did it shift 2? It shifted to the left 2 or negative 2. When it's inside and it's a horizontal shift, it shifts the opposite way of what you might think. This is a shift of negative 2 to the left 2. Now let's go ahead and let's look at the next one. Now it's probably not going to be a surprise, so I'm just going to quickly graph my original. So there's my X, okay. So now, what do you think this is? Well, this is going to be a shift of to the right 3. So this vertex is going to go to the right, 1, 2, 3. Now you could make a chart if you wanted to plot some points, or you could just realize that the pattern from there is going to be exactly the same. But it's going to look like that. So horizontal shifts are the opposite of what you might think they would be. Vertical shifts are the same as what you might think they would be. Okay, what are we going to talk about now? We're going to talk about reflecting. How do we look at something and see that it's reflected? Well, it's this negative in front. Remember, you could really write this as negative 1x squared. That's going to be a reflection. It's going to be a reflection over the x-axis. It's going to look like f of x equals x squared, so you know that that is a parabola. Let's plug in some values, and let's see what it's going to do. I bet you can already guess. So if I plug in 0, you get 0. If I plug in 1, now be very careful here. If I plug in 1, don't forget your powers come first. So 1 squared is 1. This makes it a negative 1. Plugging in a 2. 2 squared is 4. That makes it negative 4. If I plug in a negative 1, negative 1 squared is 1. That makes it negative 1. And negative 2 squared is 4, but that makes it a negative 4. So what is that graph going to look like? 0, 0, 1, negative 1, 2, negative 4, negative 1, negative 1, and negative 2, negative 4. Do you see what happened? That negative out in front reflects it over the x-axis. It made it go down. It didn't change its shape. It's still the exact same shape, but it made it reflect over the x-axis or turn down. So our last example in this section, look at this, has a bunch of different things. First of all, the graph is going to be an absolute value graph, which means it's going to look like a V. This is a vertical shift. and it's a vertical shift of positive 2. This is a horizontal shift, which means it's going to go to the left 1. And then what is this going to do? That's going to reflect it. So let's see if we can graph this without making a chart. So if you think, and I'm just going to kind of draw this kind of lightly in here, and you don't really have to. If you think of that, think of this point. What is that point going to do? It's going to shift to the left 1, up 2. So there's my new point. But remember, this is going to reflect it. So instead of going up, it's going to go down. So I could go ahead and I could look at those points. And it would look something like that. And there you go. There's the end of 8.3.